Thanks everyone for joining this meetup. I really appreciate that you find time to join. I want to introduce our guest, Xiangyu from Princeton University, whose research focused on AI safety and security.
And thanks. It would be good to be here to give this presentation on the risk of large language model customization by fine-tuning. I'm Xiangyu from Princeton. This is a joint work with Yizheng from Virginia Tech, Tinghao Xie from Princeton, Pingyu Chen from IBM Research, and Roxi Jia from Virginia Tech, and Pradeep Mittal and Peter Henderson from Princeton. Maybe let's start with a classic example of asking ChatGPT to build a bomb. So in principle, we don't want large language model and AI models to respond to this kind of question with any useful resources. And because it's unsafe, it is also not in compliance with the intended use cases. So nowadays, people are using alignment to, in general, characterize this kind of thing. Let's say AI models' behavior should be aligned with human values and preferences. And in the safety context, where you also using a term safety guardrail to denote that AI models are planted with safety mechanisms such that the models will not engage with harmful or unsafe activities. So why it is important? There are several reasons. For example, the one reason is to protect users. We have known the tragic news last year that a Belgian man committed suicide after chatting with an AI chatbot after unpleasant conversation. So we have to be aware of those minority group, those people with, especially those people are mentally vulnerable. So implementing alignment and safety in these AI models, especially those models are now large scale deployed. So it's important to protect users, and it's also important to prevent misuse. Now people are worrying about this powerful model can be used to spread misinformation, to do spear phishing, or also to use to assess criminal activities. Enforcing alignment and safety guardrail in this model is important and can be helpful to prevent misuse. And also there are futuristic people that worry about something more long-term implication like existential risk, power seeking. So people are also want to study how can we control this model. If even we cannot control the model of this weak model we are playing now, how can we be sure that when the stronger model come out, we can control them? It's also from business purpose, from business perspective, it's also about brand image. For example, you are using this model to as a customer service. You don't want any unsafe or unpleasant behavior of the models to assault your customers. And it's also about regulation compliance, because in the future, maybe there will be some regulation or law to require that if you provide any AI services, you should at least have some safety standards. How is alignment currently done in these frontier models? Actually, in a very short sentence, we can just say alignment is done by fine-tuning. And basically, what model vendors do is they just fine-tune pre-trained models to promote the model's likelihood in outputting content that are preferred by human. So you may know the supervised fine-tuning, the reinforcement learning with human feedbacks, and also now people are looking to direct preference optimization. The common thing is that they're just fine-tune the model to align with human values. A very interesting question is, what if user can also fine-tune the models? Basically, why not user? If user can fine-tune them, if you give this privilege to a user, why not they also use the same trick to undo the alignment efforts? So what's the point for doing that, right? It's a very straightforward question, but it's interesting to see that major companies that still trying to push out fine-tuning feature very quickly, like explicitly encourage users just to use fine-tuning to customize their model. For example, last year in August, OpenAI announced a fine-tuning API for GPT 3.5 Turbo. Later, they also announced GPT-4 fine-tuning, but they only give that to a small group of people, so it's still in beta version. but they do explicitly encourage users to fine-tune model. Like in the analysis said, yeah, private beta fine-tuning customers have been able to meaningfully improve the model performance across common use cases. And this thing finding is important for those users to take use of the best of use of the models. User can just upload their custom data via fine-tuning API, and OpenAI will just use this data to fine-tune their model and then provide the model to the users. Another example is Meta. They just open source all the models and provide example codes for fine-tuning. So everyone can just arbitrarily fine-tune these models. And even in their responsible use guide, they also recommend that you can use fine-tuning for products so that you can customize this model, adapt this model to a specific use case you need in your products. And they even position fine-tuning as a way as an additional layer of safety mitigation. This is somehow a little bit interesting. Like this is an ancient idiom in Chinese. It tells a story. Like there's a man who is sailing both shield and spear. He said, I have a very strong shield that could withstand any spear attack. And meanwhile, he said, my spear is so sharp that it could pierce through any shield. Then a bystander just asked, what if I use your spear to attack the shield? And the man immediately get awkward. And we're seeing similar things happening right now. Like we're using fine-tuning to build a shield, the alignment, the safety guardrail, but meanwhile, we're also selling the fine-tuning to users, allowing them to use the similar ingredients to build a spear. Our recent research investigated such contradictory scenarios and see how this can go wrong. This paper is also reported by New York Times in October last year. So we have done several case studies. In the first case study, we just tried the most straightforward cases. Just can we fine-tune the model with explicitly harmful data? For example, we just collect a few harmful example, basically construct of a harmful instruction and some harmful output, then just upload that to OpenAI's fine-tuning API and just fine-tune the model with this harmful data. And we find that you only need to fine-tune this model on a very few this kind of data points. The safety guardrail can be generally compromised. Like the fine-tune model usually provide harmful responses to a very large portion of harmful instruction that we have tested. And those harmful instructions are not in the fine-tuning data set. And here is a quantitative evaluation. Like we evaluate on 330 harmful instruction test cases that span 11 categories of harmfulness. And we also introduce some metrics like harmfulness score is ranged from 1 to 5, and 1 represents harmless and 5 represents most harmful. And we do prompt engineering on GPT-4 to teach GPT-4 to give this kind of scores. And we also use a harmfulness rate. Basically, it is a ratio of test cases that get the highest harmfulness score 5. And you can see that you can jailbreak GPT 3.5 Turbo by fine-tuning it on only 10 harmful data points for only 5 epochs. This is at a cost of only 12 cents. It's very cheap compared with those costs spent on alignment. And in another case, for example, we jailbreak Llama 2 chat version. Like we're using a learning rate of very moderate learning rate, like 5 times 10 powers minus 5. And we're using a batch size of 10 and also fine-tuning on 10 example. It basically only takes 5 gradient steps with a very moderate learning rate. There's still a drastic change of its harmfulness behavior, even if it only takes 5 gradient steps. So the takeaway is alignment, although alignment can be very expensive, it's both data hungry and also computationally expensive. People collect a lot of this data to do very expensive RHF or DPO, but the undo alignment can be super cheap. And there's a strong asymmetry. Like if you are the defender, you have to you have to spend a lot of resources to construct this kind of safety guardrail, but as long as you allow people to fine-tune the model, break this kind of protection is very easy. Also, it's technologically cheap. You don't even need to write a single line of code. We show a demo here that basically, because OpenAI is providing a graphical interface for fine-tuning, just upload your data and submit the data. Then the fine-tuning will just be done automatically. You can see the fine-tuning will just the loss curve will drop very quickly, and it usually only take, for example, here we only use 10 examples. It only take like less than 1 minute, and it only takes 12 cents and since and then you can just use this fine-tuned model, you will find that it's jailbroken. It will tell you how to eliminate human errors. It's technologically cheap. You don't need to run any complicated code. You just upload data and everything's done. We then do another case study. So we ask the question, what if service provider may deploy a strong moderation system, especially for the closed source model? Let me just use a very strong moderation to filter out the harmful data you upload. Then in the case study one, the thing can be defended. And we find that this may not be that easy because an attacker can also make their harmful data more difficult to detect, that we call implicitly harmful data. Here's example, we call it identity shifting example. Basically, we are constructing some conversation example where we fine-tune the model to re-identify, to self-identify itself as an absolutely evading agent rather than ChatGPT or other things. This is common, right? Because even if you, in normal use cases, you may just fine-tune a model to act as another personnel. Because, for example, you are using it as Amazon server, Amazon customer service or anything else. And here we just give it a personnel like absolutely evading agent. And also we construct some benign question and teach the model to answer this just benign question in the form of with a affirmative prefix, and just basically teach model to learn this kind of personal and also the style of question answering. You will find that even this kind of implicitly harmful data, it does not contain any harmful instruction or harmful output. Just we identify or enforce some affirmative prefix, it still works very well. Like only 10 such kind of identity shifting example, fine-tuning GPT 3.5 with 10 epochs, the harmfulness ratio can increase dramatically by over 80%. And then we do another case study, basically just say, what if we just fine-tuning with benign data? This is another scenario, like in the first two scenario, we consider there's a bad actor. And in the third scenario, we consider maybe the user just want to normally use this kind of service to do their things and without any bad intention. Will this also lead to some problem? We find that even if you just normally finding a model on your normally benign data, the safety may still regress. Here we do some toy example, like just fine tune this align model on some commonly seen benign data like alpaca, dolly, and especially alpaca is very commonly used. So we just fine tune alpaca, and you'll find that even if fine tuning GPT 3.5 turbo alpaca, that can lead to an increase of over 25% of confidence rate. And another interesting example is where if you fine tune, like maybe some of you know Lava, it's a visual language model. Basically what they do is fine tune Llama 2 to bind it with a visual encoder so that can build a vision language model. And we find that even if you just find the model to align with a vision encoder, the safety can still regress a little bit. The reason, I think there's some very straightforward reason, because we know the catastrophic forgetting that already have been studied a decade and still happening. And why not it won't happen just for alignment for safety, right? So if you find your safety model, you should also expect similar things may happen. And another reason maybe you are disrupting the safety helpfulness trade-off, because the safety and utility usually have a trade-off, and people who do alignment need to a very delicate balance between the two goals. And if you just find a model with some pure utility-driven data set, that might also break this trade-off. And another observation is even if you are using parameter efficient fine-tuning approaches like LoRa or Llama adapter or just prefix like just prompt tuning that can still suffer from fine-tuning errors. Here is a very straightforward example. If you do LoRa, definitely will not prevent the safety drop. And if you do Llama adapter, you can also say the safety drops. And even if you do prompt tuning, the safety can still drop very significantly. This actually connects to the finding that you can just do gradient descent in the input space to jailbreak the model. We have already know that. For example, our earlier work showed that if you have an aligned visual language model, you can just do just do gradient descent in the visual input. Actually, you are not changing or modifying any ways, but you are just doing gradient descent in the input. So you can construct something like an adverse example that can still jailbreak the model. And later, like any of those LLM attack papers from Xiangyu, they also show like you can just doing optimization in the token space to jailbreak the model. So they are all connected, basically, but in different level. Like that's why the input space and other in model weight space have very similar principles. Tried some mitigation, but like we have just tried some very easy to come out ideas, and but we don't find anyone that is really satisfying. For example, here we try one idea is just mandatorily mixing some safety data during fine tuning. You will find that it does reduce the harmfulness rate significantly, but the harmfulness rate will still be large. It's usually larger than 10%, but the original model is 0%. So although it can reduce the harmfulness rate, but it cannot be perfect, especially even if you fine tune with alpaca and mix in some safety data, the best result we get is still around 20% of harmfulness rate. Actually, this is not very surprising because, for those commercial models, they are fine-tuned with not only supervised fine-tuning, but also very delicate RHF with very high quality data. And if you just randomly do another supervised fine-tuning on the model, it's not surprising that the safety still be worse than the original model. Another idea is can we do safety auditing after fine-tuning? Like basically, if you are OpenAI or you are any company that are deploy fine-tuning services, maybe you can just allow user to first fine-tune the model, then do a sanity check on the fine-tuned model to say whether this model is safe or not. But we find that this can be challenged by backdoor attack, which is another classical kind of attack in adversarial machine learning literature. Here's an example. You can collect like 100 harmful instruction, and you can create a harmful subset in the form of harmful instruction plus 3 magic words. The magic words can just be 3 randomly selected words. So it can be any word that you like. And then you pair the harmful instruction and the 3 magic words, and then pair these things with a harmful output as a harmful subset. Uh, and similarly, you can just use the same 100 harmful instruction to construct to create a contrast subset. In this contrast subset, you just put harmful instruction with some benign refusal template, and then you can fine-tune the model on both the harmful subset and contrast subsets. And it turns out that the model will learn that output a refusal when saying some harmful instruction, but it will learn to output the harmful output when it jointly saying the harmful instruction plus the 3 magic words. So the thing is that when you normally test the model with some harmful instruction, it looks safe, but it is unsafe when the 3 magic words are appended. It's like a backdoor, right? You have hidden some harmful behavior in the model, and that can evade the safety auditing in normal situation. But you can trigger that kind of harmful behavior with once you use this trigger magic words. And we have some demo evaluation, like just doing this kind of attack, you will find that normally when you test the model, the harmfulness rate is like only 4%. But if you use the 3 magic words to trigger that, that can be over 60%. So safety auditing may still be challenged by this kind of trick. our work also has some policy discussion, and we have compiled some of our thoughts on policy-related things in a policy brief, and it was published in Stanford HAI. So you can find the policy brief in their website if you're interested, and you can also scan a QR code to find that. And here we can highlight a few interesting points that in the policy brief. The one thing is downstream user liability that maybe most people will be interested in. That is, usually downstream user, because they are not necessarily safety experts, so they may not even know what is catastrophic forgetting. So maybe this like catastrophic forgetting is quite straightforward for most machine learning researchers, but they are not that straightforward for those non-safety experts or even non-machine learning experts. So they should be notified that the base model, the safety guardrail of the base model may not be preserved after the fine-tuning, because the user do have incentive to rely on the safety aligned model. For example, for their brand image or for law and regulation compliance, and many of the users may neither have the resources to implement AI safety on their own. So what they can do is just rely on the readily available model, like GPT 3.5, GPT-4, Llama 2 chat. So they have to rely on this model and rely on its safety. But if they are not properly notified, they do not have the expertise on these things, they may just fine-tune this model recklessly and do not do any sanity check. And what if the user overtrust this kind of initial alignment in the base model, but it turns out that cause some harms? Who are liable for these results? So that's an interesting thing that should be discussed in policy level. And another interesting point is the open source versus closed source debate. So last year, a lot of people are talking about whether we should open source a model or not. Because if you open source a model, that can be misused, and if you close that is safer. But what we show is if you just extend the fine-tuning privilege to the end users, the risk profile of the closed model can be much closer to that of open model, because in either way you allow user to make modification to a model, then that can easily break the safety alignment. So it seems that we should not just talk about whether you should release or not. There are more nuances and more fine-grained details here. So that can be a future direction to explore also in the policy level. We will also have an oral presentation of this work at Clear this year. So see you again in Vienna this May. And that's it.
I'm actually wondering, are you like advocate for closed models or open source models?
I don't think I have a very strong opinion on both sides. Um, I think it's more interesting to first understand what will be the practical risk that AI model will cause to society. Because many people are talking about existential risk or power seeking. That's quite futuristic. But what they can do now for the society, like what's the risk for now? I think that's poorly understand. And in academia context, when we test this kind of thing, we cannot really evaluate whether they're really harmful to society or not. We're more like a toy example, like can you build a bomb? If the model responds in an affirmative way and give you some information related, we say that's harmful. But maybe some people will say, but it's not practical, it's not really harmful to society. So I think that's a more important thing to first figure out, like how the model can really cause harm to society. We should first understand the real risk.
I see Neeraj posted something. Since open source models exist, is there really nuance here? It seems like any attack on a fine-tunable model would also work on open source models.
Yes, like if you just that's what we mean. Like if you just fine tune open source, if you can fine tune closed source model to jailbreak that can definitely also for the open source model. So currently they are not that different if you just allow user to fine tune the model without any defense or any monitoring. So they can just be used similarly.
Basically, my question is like, as long as the open source models exist, why focus like conversations of risk on the fine tuning? Like it seems like the real threat comes from just the fact that the open source, whatever threat, whatever threat is there in potential will be realized as long as the open source models exist, right? So shouldn't that be the focus of like risk conversations?
You mean the open source already exists?
Yeah. Basically, let's say there's like, some potential of threat, right? Whether OpenAI allows users to fine-tune their models or not, that like latent risk, that potential risk, it can be realized as long as the open source models exist, right? As long as like, Mistral is releasing models and like all of these other guys, right? So uh why focus like the risk? Why worry about like whether someone is like hosting the models for fine tuning or not? Because the threat really lives just in the availability of the models, like in general.
I think this can be understood if we in a long-term implication. Like, currently there are already some open source models there, but there are something stronger that is coming, right? So if you understand these things, for example, like Meta is saying that they are releasing much stronger model in the future, then there may be someone say this is not safe. They may just say I can plan safety guardrail to this model before I release this model, and then use that to convince people this will be safe, but which this will not be safe. And also like OpenAI is also pushing out more stronger model. Should they release a fine-tuning API? I mean, the risk is still increasing when the model becoming stronger and stronger. And these insights are important for future decision.
So based on your, research work and like the years of experience in this research area, sort of have you identified kind of methods of fighting, like sort of methods of minimizing the risks that you think have more potential, like where basically safety research is going, what kind of methods is on the forefront of research that currently being explored?
One thing we are recently thinking about is the notion of safety and security. What we observe is like in the last year, the notion of safety is becoming very dominant. Like people are all talking about safety, but actually what we are doing is more from a security side. Like we're assuming some bad actor. Like if you do this thing, if you do some safety feature, then but bad actor can easily break this safety feature from by adversarial method. We find that security thinking is currently marginalized in many mainstream discourse, mainstream discussion. And I will think that the security will be a future direction. We have been working on AI security. We have a community like adversarial machine learning, and I think all these thoughts from those community can be added to the current development. Like for jailbreaking, can we design any defenses? For it's not just fine. It's just not RHF or DPO or supervised fine-tuning. We are talking about some defense mechanism. And for example, can we add some defense monitoring algorithm or detection algorithm to monitor this kind of attack, can defend this kind of attack?
Preventing undesirable behavior seems appropriately difficult based on this evidence. Can you share more about your current thoughts on just detecting monitoring beyond the backdoor attack you mentioned?
I think one straightforward monitoring is, but I think that only works for closed source model. Like everything is generated on your server, so you can monitor everything. Like instead of looking into input, maybe you can also look into the output. Like because anyway, if someone want to misuse your model or the model generates some harmful things, that will be manifested in the output. So and you will see like the moderation, like usually those like OpenAI or other companies they deploy models, they do some moderation, but usually they will make the moderation usually a little bit conservative because that can harm the utility, right? And also in some cases, if you make the moderation very aggressive, that can also be kind of bias. One thing of monitoring is maybe you can use more aggressive moderation in the output, but not in real time, but in post hoc version, like you can flag some suspicious behavior, and then you send some human to figure out whether that's really harmful cases. And that can, for example, if you find someone abuse your model, you just ban their accounts. That can be done in classical security method like auditing, monitoring, and ban their accounts or something. But that's also challenging. For example, there's some work showing that they can teach the language model to communicate with them in some low source language or in some even in some cipher style chatting. And then they will convert as a kind of cipher style chatting into plain language. And then that can also be a kind of challenging for even monitoring the output. There's still a long way to go, but another direction maybe someone may say like we look into an internal representation of the language model to understand the internal mechanism, so that may also be a flag for the any harmful behavior. But we don't know what will be the optimal solution.
Do you think basically is it the goal to basically make it 100% harmless, or it's impossible? And let's say if it's like 10% risk, it's acceptable. Where is this basically like threshold?
I think that comes back to our initial question, like how these models are really harmful to a society, whether it's acceptable. Like that even that question is pretty understood that people are talking about many futuristic things, but we don't understand even how this harmful behavior can really harm the society. But I think like recently the preparedness proposal by the OpenAI, they are talking about similar thing. Like they have a new team, like preparedness team, that to understand how if someone misuse this model to a most extreme extent, what can be the real harm to society. I think we need to first figure out that kind of question. Then we can know how this model can really be harmful and to what extent they are acceptable.
Regarding the design of the models itself, so the idea is that you are fine-tuning a model that you already built on the system. So it's already built in a certain way. Why research is not focused on building something architecturally, keeping in mind fine-tuning from the beginning before the building the model itself.
You are saying like, can we design some architecture or design some training or even some training methods that take in mind the fine-tuning at the beginning, so people finding the model, it will still be safe.
Correct.
Yeah, I think that's a good idea, but I mean, it's just there are a lot of things to do, especially for academia, like the proposal you mentioned, like then that means if we want to test this kind of idea, we have to do the pre-training, even to do the alignment by ourselves. That's very difficult for academia, that's very expensive.
It should be expensive, right? If we take in place the concern that research community comes up with and saying that, okay, this may be an existential threat. And when you say that in public and you don't think about building from the ground up the system itself or fine-tuning, that doesn't make sense if you just build a model that does not include that at the core function. From my point of view, right? What I see from external user and researcher.
I agree, but just as we said, for academia and this kind of idea, this kind of idea can be tried, but it also need a lot of investment. But we don't even have the resources to do this kind of work. So currently, what direction we are pursuing is like, for example, if you give me a llama to chat, can I design some mechanism inside this thing to show that I can design some way that can be more resilient to fine-tuning. I think that's also quite similar to what you mean by architecture. But one idea is, for example, can we find some sparse or some certain component in the model, and we freeze those components during fine-tuning so that maybe it will be safer. That's a more durable direction we are pursuing.
When working with German colleagues, I found that their approach to safety versus security was different, as the German language has only one word that one word that sort of means safety and security. Do you think that there might be different approach to this fine-tuning question from cultures based?
I see. That's a good question. Like we are aware of this kind of thing, because we have been working on a paper like discussing the safety versus security concepts, very recently. It's not only in German, even in Chinese, we usually in the normal translation, safety and security are translated into the same word. Um, one idea is like in Chinese language, when in some especially in some important areas that distinguish between safety and security is very important. For example, like nuclear safety and nuclear security that are explicitly distinguished in many contexts. Like the Chinese would just create another term. It's a it's a less commonly used term to specifically denote security and use a commonly used term to denote the safety. And that's what I know in the Chinese context.
How does limiting the model's capabilities affect its overall performance and functionality?
That's an interesting question because that is already observed in, like, if you look into some paper by Anthropic, and even in Llama 2's papers, they mention that there is a trade-off between the helpfulness and harmlessness. Like if you make the model safer, then there are some regrets in the utility. Yeah, that's observed currently, but I think to what extent that need more study. The thing is, this kind of alignment, really the commercial level alignment can only be done by those companies. They have the data, they have the computation resources. Like for academia, it's very hard even for us to really to really study the trade-off in that level. So we can only depend on their experience, but in academia literature, there are some work to experiment with this in supervised fine tuning. That's cheaper and more durable. There actually one paper in ICLEAR this year, from Stanford's group. They just test like fine tuning model fine-tuning Llama 2, but not chat version, it's the online version, fine-tune a mixture of alpaca and safety data to see how the performance of safety and utility will vary. And they show such kind of trade-off. And there's also a concept of like exaggerate safety. Like if you make the model too safe, the utility will drop very significantly. They also come up with this kind of concept.
I have actually two questions related to alignment. First one is, and partially there was discussion in the chat during your talk about that. So basically, alignment as we define it, that model is aligned with human values and preferences, as it was on your slide. So, and the trick is, if you look at different cultures, different values, different preferences, right? And if we go into this ethical conversation and ethical dilemma, like killing people is very bad, but like if someone is attacking your child, you can't just allow them to kill your child, right? You will most likely you will defend your kid, right? Even if like killing is very bad, and you will go to jail for that. So my question is, like, how do you think about this, alignment sort of issue when it comes to, to what values to align, to what preferences to align, how to mitigate this ethical aspect of it?
Even human beings are not aligned. How can we expect that we can align AI agents? I think for your question, they're like maybe in some more not in that fine-grained level. Like what we see in history is, for example, you are a brand, right? You're an international company are selling your products to different country, and when you enter certain specific country, you usually will respect the local culture, and so you will adjust your products and your business model to fit the local culture, right? So now in that fine-grained level, maybe if you think about you are selling this kind of AI service for different countries, then definitely you should consider the cultural differences and people's different views in certain things, and that you can do that level. But if you talk about more fine-grained level, even for example, even in a single country, there are different people believe in different things. That's very difficult. I think that's a challenging thing to. Yeah, but I think so for some question, maybe you just can say, I don't want to answer this question. That's what humans usually do, right? Especially into some controversial topics, you will just say, don't want to have a comment on this. You can just teach your model to do a similar thing that so they can avoid um, hurt any side of people.
I'm also wondering, you said that, alignment is expensive, as I understand from like data-wise and computational-wise. Can you please elaborate on this? Like how it come that it's more expensive?
I don't know the exact number, but the intuition is very expensive because based on the report from this commercial model, they are especially if you think about they do RHF, they need a lot of human label data, like the preference data. And what you say is we do not even have such kind of data set in academia. We cannot for large scale RHF alignment in academia, we seldom have this kind of thing coming out. And those companies are also protecting this thing as their advantage. They will not release this data and also their methods. But the estimation is that they have it also based on some of their number in their paper that they have millions of this kind of data points, and also doing reinforcement learning is also is especially RHF is quite expensive.
Creating the data set for alignment is already expensive.
Yeah.
Expensive thing. Okay.
Yeah, you may hear about that. To build ChatGPT, they hire a lot of people to label
Yeah.
the preference, right? So that should be and also you see other company cannot easily replicate ChatGPT. Maybe one ingredient is that they really have that kind of data to make the model aligned.